Alright, so we're getting started here with our classification video, the second of three. So I'm just going to kind of pop into the slides here and continue on where we left off. So we start with the definition of classification. We're talking about our data within our attribute tables here. So a lot of times we'll have a lot of features in our shapefiles, for example, maybe thousands of features, hundreds of features, and it wouldn't be very practical, if you will, to show them in as unique values for each one. That would just create a very large legend. And so what we do is we create what I call buckets. I use this term in class a lot of times, but I also refer to them as classes, which is what we normally call them in GIS. So if you think about numerical values, and we just talked about data types, nominal, ordinal, interval, ratio, and cyclic data. In this case, we're talking about taking ratio values or numeric values that we can actually do math and statistics on and grouping them together into what we call classes, or these buckets as I like to call them. So that's the process of classification. And so what we're going to look at is a couple of different classification schemes here quickly. But what this really does is produce what we call a choropleth map. And so a choropleth map uses these different colors or patterns, which a lot of times with GIS we do have, again, all those different options available to us, but I usually don't see a lot of maps these days using a lot of patterns. We usually use the different colors to show different values over space. And when we say space in this case, we're talking about typically areas. So we're talking about polygons primarily when we're talking about creating what's called a choropleth map. And so this next slide shows what a choropleth map is. This is an example of one. And so you can imagine showing all of these individual counties. So we see the states layer in a thick black outline, but then we have our counties layer, which is in slightly lighter gray outline, but also filled with these different colors, which means that they correspond to a different class. So if you were to look at some of these numbers, and we're looking at the Northeast United States here in the area around New York City, Philadelphia, Baltimore, Washington, D.C., large urban areas, that's where we could expect to see our highest populations. So in this case, this county layers we're showing according to a field in the database, whether it's a feature class in a geodatabase or a shapefile, on the POP 2003 field. That means that that is the population in 2003. Of course, that same shapefile could have several other fields that we would symbolize the data on. So in this case, we've gone through and said, you know what, we're not going to show every individual value. Again, that's not very practical to show every individual population value for all of our polygons representing counties. So what we do is we create classes. And that's what creates this choropleth map. So we see that the lightest colors are going to be in the -99 to 162,000 range. And what that means is that that -999 indicates that there was no data there. Obviously, we're talking about absolute values where 0 means nothing. So if we were to click on one of these polygons, we would see an actual population value. But the lowest value in this particular data happens to be -99, which means there was probably no data, no known data for that population. So it's actually taking, for that county. So it's actually taking that -99 value and putting it in here. What might be a good idea is to maybe exclude that -99 and just put 0 in there. But what that would do is it would take anything that has a -99 and put a blank polygon in there. So that's something that if you're making this kind of map, you may want to disclaim that. And then of course we're showing these different ranges for where the population for each individual feature actually occurs within these different ranges. Again, a basic choropleth map. We will talk about counts and amounts throughout the course. When you talk about counts, you're actually talking about the number of features in your actual data set versus amounts, the actual amount of something at that particular feature. So in this case, we may have several hundred counties in this one particular area, but each county has a different amount in terms of its population. So the count is how many features. If I clicked on this one feature here, that's one feature, or these 4 features here, that's 4 features. But the total amount of population in those 4 counties, for example, would be from that population 2003 field added together. So there's a difference between counts and amounts. So bear that in mind as we start moving forward talking about our data in different kinds of ways. So different classification types. Natural breaks is the default ArcGIS will default to natural breaks when you tell it that you want to show your data based on some sort of quantity. And so this is also known as the Jenks classification, Jenks. You'll read that in your book, in the Theobald book. And again, this is the default classification scheme that ArcMap chooses, and it looks for where there are breaks that are sort of natural within the data, or natural groupings. It looks for basically where there are features, groupings of features within a particular class. So if there's a lot of features that fall within the 3 to 6% classification of this percent population under 5, then it would group them all into this class. But then if there's a bunch of features that are kind of grouped together, a large number of features that fall into the next category, it would create that category. So again, that's natural breaks, these sort of natural groupings within the full distribution of your data. And when I say distribution of your data, I'm talking about the values for every feature in your data set. So again, looking here, thinking maybe there's about 1,000 polygons here, maybe there's 500 polygons here. There's a low value, there's a high value, and then there's everything in between. And so what it's doing is it's looking for groupings of the number of features that fall within each of the different classes. Again, that's the default classification scheme. Another one that you could choose that's very good for linear distribution of data, or data that's linearly distributed, you'll read that in your chapter as well, is quantiles. So what this does is, as the second bullet indicates here, it puts its class breakpoints with the same number of features. So the easiest way to do that is to imagine there being 100 polygons here, and so if we wind up with 5 classes, each one of those classes is going to have 20 features within it. Sometimes that works, sometimes that doesn't. You got to think that sometimes you won't have that perfectly even number of features. And another thing is that you may have 2 different features, for example, 2 different counties that have the exact same value. Chances are, in terms of population, they might not be exactly the same, but you may have some sort of polygon, point, or line that has an exact same value, but if it falls on the edge of one of these class breaks, it would actually put one value in here and then the next value in this class over here, even though they have the same exact value. But that's because the quantiles classification scheme breaks it down into the same number of features for each of the individual classes. So something to think about as you're choosing which classification scheme is the best for showing your data. Remember, there's a story that we're trying to tell with our data, and we have a lot of control over that, and that's one of the things that I stress to my students in class, is that you as the cartographer, you as the GIS specialist or analyst or technician, really wield a lot of power in how you choose to show this data. And we'll see what I mean by that when I show you some of the examples that we were talking about in the PDFs that I've given you guys as part of the resources for this module. A couple of ones that I don't have screenshots for but are very similar are defined interval and equal interval. So in the case of defined interval, you actually go into ArcGIS in the symbology tab and you go into the classification button and you tell it, I want my interval to be 1,000. And that's going to be the interval between the lowest and the highest value for each of your individual classes. You got to think about how your data is distributed. Again, if your lowest value is in the 10,000s and your highest value is up in the millions, well, maybe you don't want to specify an interval of 500 because that's going to create way too many classes. You're going to start from 0 to 500, 500 to 1,000, 1,000 to 1,500, and so on and so forth. And again, that would be very impractical. Remember what we said in one of our earlier lectures, 5 to 7 categories max. So if I kind of go backwards here, we're sort of already at the getting close to the limit in terms of the number of categories that we've chosen here. Maybe it would be better to group this into just 3 categories for the purposes of simplicity. However, that's going to change the map, so things to consider. So again, if we're looking at values down in the 10,000s and as high as in the 100,000s or the millions, maybe we would want to specify an interval of 50,000 or 100,000, which would still create several classes. Maybe if we were in the low millions, 1 to 2 million, we would do an interval of 500,000, which would maybe create 3 or 4 different classes. Equal interval is similar in that instead of you specifying as the user the number of classes, it takes the entire distribution of your data for that particular field and divides it equally into equally sized subranges. Now, it's very similar to equal interval. It's fairly intuitive to map readers, as I say in the last bullet there, but you got to understand that it could produce something like what we saw in the first choropleth map, where it's going to pick these values that are not necessarily very intelligible to the average person. It might be better to show these values sort of nice round numbers from 0 to 200,000, 200,000 to 500,000, or something along those lines. So as I jump back here to this equal interval, you just have to remember that with equal interval, the difference between the lowest value and the highest value for each class is going to be the same. So that's why we say that it's similar to defined interval, but in the case of defined interval, you are choosing what the interval is going to be, whereas ArcGIS is sort of doing the work for you with equal interval. One of the other classification types that you're going to see is standard deviation. You may or may not use this. Now, the thing with standard deviation, obviously you're looking at how your data varies around a mean or an average of your total data set. So we're not actually showing the actual values of the data on this particular map. We're showing how much each of the polygons varies from the mean. So for example, if we're looking at these sort of grayish, tannish looking polygons here, the population under the age of 5 for each of these light colored polygons is right around the average or the mean for the entire data set. And that's really key to remember with that standard deviation. As you start to get into these populations or these counties that have populations that are 2.5 or 2.5 to 1.5 standard deviations below the mean, obviously these are polygons that have populations that are well below the average for the entire data set. So they're below what these polygons are in terms of their population, and these guys right here in the lighter colors are right around the average for the entire data set, and vice versa. If you go down to standard deviations above the mean, we're seeing that some of these darker colored counties have individual populations that are well above the average for the entire data set. So we're just basically looking at measures of central tendency here with regard to our standard deviation. So those are some basic classification types that you can choose. You'll work through this with the chapters 5 and 6 and showing this, but we'll also show them in the next video, where we're going to look at some basic data for population, different populations for the state of Maryland by very simply the 23 counties and Baltimore City. So we'll see that in the demo here. I did want to address normalizing data because you got to think that you're going to have multiple attributes within your data, and you may want to normalize your data, which means that you're going to be dividing one numeric attribute by another to minimize those differences based on the size of an area or the number of features in a given area. So that's that first bullet that we're reading there along the top, but I really like to talk about the examples here. If you're interested in looking at what percentage of a total population for a bunch of polygons, say a bunch of counties in Maryland is, in this case I'm using 18 to 30-year-old population, you have a total population for each polygon as well. So those 18 to 30-year-olds, maybe you have 1,000 18 to 30-year-olds living in a particular county, and the total population is 10,000. So 1,000 is 10% of 1,000 is 10% of 10,000. So that 18 to 30-year-old population basically yields a percentage, 10% of that total population. Another way to do it is to divide a value by the area of the polygon. So that's going to give you a value per unit area or density. So your population per square mile, for example. And again, we're going to see these in the demo, but I did want to just address this because normalizing data is something that can very easily be done within the symbology tab of the layer properties, and we'll see how that works within the demo. You could also have fields in your database, in your attribute table, that hold the percentage values, and that's completely up to you depending on the utility of that field, if you want to have it permanently within your data or if you want to just let ArcGIS do it through the symbology tab. So we'll see normalizing data as an example in our demo as we go through it. And so the last thing that I really want to kind of touch on here from Theobald, page 127, you got to understand that there is a story to tell with your map. There's no correct way to classify your data. There's no correct way to choose what the best symbology or symbolization of your data is when you're classifying your data. You're taking these numeric values and you're putting them into classes. You can slice it an infinite amount of ways. But we're going to see the different types of stories you could tell using some of the examples that I mentioned earlier in the first video, and we'll also see kind of how we can sort of build a narrative around the different populations of the counties within the state of Maryland. So it really depends on your data, how your data is distributed, and what story you're trying to tell. And again, that gets back to the idea of you sort of wielding a little power here in terms of the analyst, the specialist who is creating the map based on a particular data set. So just remember that there's no correct way to classify data. There's no right or wrong way here. You have to play with those different classes and the ranges for each of the classes to basically illustrate what you're trying to say with your map. So I did want to just sort of have a wrap-up slide here before I jump into my examples. Chapters 5 and 6 in the Green GTK book are the two chapters where you're going to be practicing a lot of this classification and symbolization that we've talked about in these last two videos. And of course I'm going to be posting the assignment 3 materials, which is basically all of the data from exercises 5 and 6 bundled together so that you can then create your own version of the Africa Atlas that you create in chapters 5 and 6. You come up with a fairly generic look and feel to the maps in chapters 5 and 6. So your assignment for assignment number 3 is to come up with your own Africa map or series of maps within your own assignment 3 MXD and create a map. So you'll see that in the instructions, you'll see that within the module. So I just wanted to give you a quick run through of what we're going to be expecting to do in terms of the work for this actual module. So I'm going to jump out of here really quick, and I'm going to go to these to this set of 3 maps. These are all choropleth maps that I've actually personally worked on in the past, and so you'll notice that one of them is called Charles 75K, one is called Charles 100K, and one is called Charles 150K. So what I'm going to do is I'm just going to open up the 75K map. I'm going to zoom out on this just a little bit so you guys can get an idea of what we're looking at. So the sample here, this is an example of a map that I worked on several years ago. We were trying to show the distribution of wealth in the Baltimore region, and that's because of a conference of high-end retailers in Las Vegas on a yearly basis. We're trying to basically draw some of high-end retailers, your Bloomingdale's, Saks Fifth Avenue, those kind of things, those kind of companies into the Charles Street corridor, where in some places on Charles Street there are a lot of what's the word I'm looking for here, guys? A lot of renovation is going on, a lot of redevelopment is going on within that area. So we're using the Washington Monument sort of as our central point within the city to measure our 1 mile, 5 mile, and 20 mile radius. And so we're trying to get an impression of where the distribution of wealth is. So if we were to look at the legend for this particular map, we could see the number of households making $75,000 per year. Now, that's not an individual. Those are not individuals. That's individual households. So that could be 2 people, one person making 40, one person making $35,000 a year. So we're not talking about super high end in terms of income ranges, but 75,000 is one of the ranges that our client wanted us to look at. So as I sort of reset this map here and look at where my other maps relative to the 75K map sit, you can see how they kind of change. So we're trying to tell 3 different stories, and so the threshold was 75,000, 100,000, or 150,000. We wanted to see how many households were within a certain proximity of that corridor, so we could see who would actually patronize those establishments. Is there a distribution of wealth in the Baltimore region that would actually be able to support those kind of high-end retailers if they relocated to this Charles Street corridor, which you can see I've highlighted here in red as well. So the thing is, we can tell a different story with the different fields of data within the shapefile or the feature class that represents these. These are block groups. These are different groupings of census block groups around the Baltimore area, which we have income values for. So if I were to click on this and again hit my 75K map, well, we can see we've got a lot of blue in the area. We've got different ranges of blue, which again give us our highest number of households with $75,000 a year income. If I were to switch that map to the 100K, you can already see how it starts, and I'm just going to kind of use my resources here, just kind of flicker back and forth, if you will, between these 2 PDFs and see how things start to get a little bit lighter. So I'll bring that 100K map up and we start to see the things start to lighten up around the Charles Street corridor a little bit. And if you take it up to the highest level, you can really see that we're talking about areas making $150,000 a year within the Baltimore area, where they're very concentrated up here in the northern parts of the county, maybe over here into Harford County, Howard County, the Ellicott City, Columbia area. But immediately around the Charles Street corridor, this is probably maybe some areas around the northern part of Baltimore City, Roland Park. We can see starts to get a little bit dark there. So we're saying that there are a higher number of households within those areas, but immediately around the Charles Street corridor and areas that maybe that high-end retailer may serve really starts to get sparse. And we start to see here that we're seeing anything in yellow. We have 0 households that are making $150,000 per year. And over here in this table, we're indicating that within each of those different mile radiuses, that the number of households really starts to go down. So my question to you, and I'll let you guys sort of hash this out for a second or two in your head, which map do you think they decided to go with? 5, 4, 3, 2, 1. Absolutely, you're right. They decided to go with the 75K map. That shows that even as a household, $75,000 per year, some households that are making that amount may still frequent some of those establishments, and you're telling sort of a sparse story by showing that highest value, that $150,000 per year. Range really doesn't look like it supports it. So the choice was made to go with the 75K. It seems like, again, we're choosing how to show this data, what story we want to tell. Someone that wants to read into this map a little bit more might break that 75,000 down into 2 people or maybe even 3 people making a total of that amount, and they're not necessarily going to support the type of retailers that want to maybe potentially relocate to the Charles Street area. The point to all of this really, guys, is that I, as the cartographer, had to make a couple of choices as to how I'm going to represent this data. We put it in front of our client, and our client went with one of the 3 maps. Obviously, we weren't going to show all 3 maps. They wanted to see what the distribution of wealth was within one of the categories. The category they chose was the 75,000 per year. So there is a book out there by an author by the name of Mark Monmonier. He is the author of How to Lie with Maps, and that's something that I recommend to you if you get the opportunity to pick that up and read it. Definitely check it out, because we have a lot of, again, we wield a lot of power in terms of cartography and GIS with how we show data. So that's a real significant story that we can tell there, and we have a lot of control over that. So I'm going to wrap up this video now, and I'm going to go ahead and jump into the demo with the next video, and we'll see how we can show data in different ways, and symbology wise and also classification, and that'll wrap up the videos for this 4th module, and for you to be able to get into your exercises and work on assignment number 3 so you can start to apply what you've learned.